start back here. This is notes on 12.3, the quadratic formula, day 2. So question 1 says the quadratic function h of t is equal to negative 16t squared plus 20t models the path of a dolphin jumping out of water, where t is the time in seconds, and h of t is the height in feet. Graph this on your calculator, adjust the windows as needed, and sketch the parabola on the graph provided. Label your axes. So we're going to go to our calculator, hit y equals, and we're going to type in that equation. Because we're given t's and we don't have a button to type in t, we're just going to use x when we type it into our calculator. So you can type it in and then hit graph to look at a picture. So it looks like it crosses my x-axis at the origin, and it crosses over here, and I can draw in that parabola. Okay. Label my axes. So my x-axis is, well, in this case we're using t is time. So my x-axis I'm going to label time in seconds, and my y-axis is going to be my height, and label would be feet. B says at what time, so we're solving for t or x, does the dolphin reach the water? So when it reaches the water, the height is going to equal 0. So we are essentially looking for this point right here. So I can set my height equal to 0. So we would have 0 is equal to negative 16t squared plus 20t, and I need to solve this for t. So in other words, I can factor, or I can use quadratic formula. In this situation, I'm going to use quadratic formula because factoring that does not look very easy. So my a value would be the negative 16, my b value is the 20, and then my c value is 0 because I don't have a constant. So I'm going to start by plugging my numbers in. So it's negative b, so negative 20, plus or minus the square root of b squared minus 4 times a times c, all over 2a. I'm sorry, not a, 2 times negative 16. Okay, let's start by cleaning this up. So I'm going to have negative 20 plus or minus the square root, and I'm going to type in this, what's under the square root. So we have parentheses 20 squared minus 4 times negative 16 times 0, which is 400. Over, and then 2 times negative 16 is negative 32. So now I can split this. So t is going to equal negative 20 plus the square root of 400 over 32, negative 32, or t is going to equal negative 20 minus the square root of 400 over negative 32. So in my calculator, negative 20 plus the square root of 400, enter, and then divide by negative 32, which gives us 0. So t is equal to 0. And then type in the other side. So negative 20 minus the square root of 400, enter, divided by negative 32, gives us 1.25. So t equals 0 would be the point at the origin, and t equals 1.25 must be my other point, the one we were looking for. So t equals 1.25 is going to be my solution. So we could say the dolphin reaches the water at 1.25 seconds. And we can kind of see that this graph mimics the dolphin jumping out of the water. He starts here in the water, jumps out, and then comes back and lands 1.25 seconds later. Big idea for today is when we ask you about time, you are looking for an x-intercept. I'm sorry, you're looking for an x value. If we're asking about when the object reaches the ground or water, that means the height is 0, or our y value, if we're not measuring height. So when the height is 0, that tells us we're looking for an x-intercept. So to say that again, when we're asking about time, that's looking for an x value, because time is going to be on our x-axis always. When we're asking about when the object reaches the ground or the water, our height or our y value is going to be 0. And when you're trying to solve a quadratic when it's equal to 0, your options are to factor or to use the quadratic formula, because you're looking for those x-intercepts. Alright, you can do 2 the same way that I did 1 above. So you're going to use your calculator to graph it, and then it says at what time, so that's an x value, does it reach the ground, which means the height is going to equal 0. So you can factor or use quadratic formula. Use the quadratic formula. Okay. On the back, it says graph the quadratic function using the 5 key points. Show your work algebraically, then complete the following parts. So I'm going to do this one with you. So it wants us to first find the x-intercepts. So I'm going to set this equal to 0. And I'm going to tell you that this is not going to be able to be factored. So we are just going to use the quadratic formula. So my a term is 3, my b term is -2, and my c term is -4. So we're solving for x, it's negative b, so it's going to be -2 plus or minus the square root of b squared minus 4 times a times c all over 2a. Clean this up, we would have -2 becomes +2, and then type all of that into my calculator. Make sure I put the parentheses around the -2 when I square it. I get 52. And then 6. So I can split it now. So x would equal 2 plus or minus the square root of 52 over 6. Sorry. 2. Okay. And then x would equal 2 minus the square root of 52 over 6. So when I type them into my calculator, we get 1.54 and -0.87. So those are my 2 x-intercepts. So I can plot those points. 1.54 is going to be somewhere between 1 and 2, and -0.87 is going to be like almost -1. The next thing I need to do is find my vertex algebraically. So the x value of my vertex can be found 2 ways. I can either average my x-intercepts, or I could use this formula, -b over 2a. So I'm going to use this new formula, so it's going to be -2 over 2 times 3. So -2 becomes a +2 over 6, which is 1/3. So the x value of my vertex is 1/3. To find the y value of my vertex, I'm going to evaluate my equation for 1/3. So we would have 3, and then instead of x, 1/3 squared minus 2 times 1/3 minus 4. And when I type that into my calculator, you get -4.3 repeating. So my vertex is at 1/3, -1, 2, 3, 4, and a little bit. So about right here. My axis of symmetry, remember, is always x equals, and it's the x value of my vertex, so it's going to be 1/3. My y-intercept is always my c value, which is -4, so my y-intercept would be 0, -4. This is going to open up because it has a positive a value, it's going to be a stretch because my A value is bigger than 1. Since it opens up, it has a minimum, and that value is going to be the Y value of my vertex, which is the negative 4.3 repeating. My domain, all real numbers, and then my range, Y greater than or equal to that min value of negative 4.3 repeating. So I'm going to plot all my points. So negative 0, negative 4 would be right here, and I could also put a point mirrored on the other side of my axis of symmetry. So remember, my axis of symmetry was 1/3, so it's 1/3 to the left, so I could go 1/3 to the right, and there would be my 5 points to graph that parabola. So you guys can do 4, and then when you're done with 2 and 4, upload a picture.